Alright, dear children, now we move to the next process. As I said, that is called adiabatic process. So this is one of the important thermodynamic process, okay, which takes place in such a manner so that there is a change in pressure, volume and temperature. Means all this physical quantity will change. Pressure will change, pressure, volume and temperature changes. Pressure, volume and what? Temperature changes. Okay, and such change which takes place, okay, under the condition that there is no exchange of heat takes place between the system and surrounding. That means pressure, volume and temperature changes. I am writing the statement changes under the condition, okay, I am writing under the condition that there is what? There is no exchange. There is no exchange of what? Heat between. There is no exchange of heat between the system. Between the system and the surrounding. There is no exchange of heat between the system and the what? Surrounding. And such process which takes place, okay, a thermodynamic process which takes place is called adiabatic process. So children, remember this, that adiabatic process is one of the thermodynamic process in which there is a physical change takes place with a change in pressure, volume and temperature, okay, under the condition that there is no exchange of heat between the system and the surrounding, which means Q is simply 0. See, you have learned in detail in the previous chapter also, adiabatic process, okay, the same process you are learning but in more details. But remember this, in adiabatic process Q must be 0. Q 0 means the process, there is no exchange of heat between the system and the what? Surrounding. Okay. Now, this process takes place under a necessary condition, and the condition is the heat should not be exchanged between system and surrounding. And this can be observed, by taking the system in a perfectly insulating surrounding. Perfectly insulating what? Material. So let me just write down, system must be what? Must be taken in a what? Perfectly insulating material. Now this is just like opposite to what? Isothermal process, because in isothermal process, as you know, that the system must be placed in a perfectly conducting material, but for adiabatic process, the system must be taken in a perfectly insulating material. So when you take this system as a perfectly insulating material from the surrounding, so under this condition, what happens? If any heat that is produced inside the system, that the heat does not go out from the system to the surrounding. So that when the heat does not go out from system to the surrounding, what happened? Then definitely what happened? The temperature of the system increases. Let me just take, there is a system, okay, bounded by a perfectly insulating what? Material. Like, let me take the system as a gas. Now out here also we take system as a what? Gas. Suppose there is a system as a gas. Okay, so under isothermal adiabatic process, if I take a system like as a gas, and that gas can also be a what gas? Ideal gas. And if this system is completely bounded by, say, perfectly what? Perfectly insulating what? Insulating material. Then what happened? As I said, that if any heat produced inside the system, that heat will not go out from the system. So that the temperature of the system what? Increases. The temperature changes. Temperature changes means the temperature of the system increases. Okay. Now, the other process can also be happen, that if any heat is absorbed by the system, and that heat cannot come out from the surrounding, so that the temperature of the system what? Falls. Now this is simply the absorption of heat and the release of heat which takes place, that if any heat which is produced in the system, okay, that means the temperature of the system increases, and in case if any heat that is absorbed, that there is no heat can come out from the surrounding, in that case what happens? The temperature of the system falls. Means no exchange of heat takes place between the system and surrounding, which means Q is 0. If any system does not take any heat from the surrounding, the temperature of system fall. If there is any heat produced in the system and that heat cannot go out from the surrounding to the surrounding, the temperature of the system rise. So that means in case of adiabatic process, the temperature will not remain constant. Like in case of isothermal process, temperature was constant. But in case of adiabatic process, temperature will not remain constant. That's why in order to not to keep the temperature constant, so much we keep system in a perfectly insulating what? Material. But children, one thing you have to keep in mind, this consideration of taking perfectly insulating material is only a theoretical consideration. This is only case under ideal condition. Because in actual practice, there is no material which is perfectly insulating. There is no material which is perfectly what? Insulating. That's why perfect adiabatic process, like this is adiabatic process, but perfect adiabatic process, okay, is actually impossible. So let me just write it down, the point. Perfect adiabatic process, okay, perfect adiabatic process is impossible. It cannot occur. Like you learn in isothermal process, perfect isothermal process is not possible. Similarly, perfect adiabatic process is not possible. Why? Because in actual practice, as I said, perfectly insulating material is not made. It cannot be there. Okay. Now, but this process can take place not slowly, but this process can be observed very rapidly. That's why one point you need to keep in mind, that adiabatic process can be observed very rapidly, whereas in case of isothermal process, the process was observed very slowly. But in case of adiabatic process, to observe, it can be observed very rapidly. Okay, that's why when the process takes place very rapidly, so that the heat does not find any time to flow in and out from the system and the surrounding, then that process is called adiabatic process. That's why adiabatic process is not a slow process, it is a rapid process. Because in actual practice, when you observe this process, the process has to be occurs very rapidly, so that the amount of heat does not find any time to flow out between the system and the what? Surrounding. Okay, that's why it is a rapid process. And children, one point you need to remember out here, that the process being very rapid, okay, is actually not the theoretical consideration of adiabatic process. This rapid process is only under practical purpose. So for theoretical consideration, means if you take a system under a perfectly insulating material, okay, then even at a slow process, okay, even at slow process taking place in a vessel consisting of gas like a system in a perfectly insulating material, this adiabatic process can be observed. But this is only under theoretical consideration. That's why in order to observe adiabatic process in actual practice, okay, the process has to take place rapidly. Otherwise, this process cannot be observed at all. That is very important. Okay. Now, the next thing that we need to keep in mind is that in this process, neither the pressure will remain constant, the volume will remain constant, the temperature will remain constant. So, when we take a system as a what gas? Say ideal gas. Again, we take the consideration of ideal gas. So, this chapter is completely based on ideal gas. Means these two processes that we are learning out here must be observed by taking a system as a what gas? Ideal gas. So if I take a system as an ideal gas, then this adiabatic process actually follow one of the law known as Poisson's law. So one of the law it is followed known as what? Poisson's law. So children, adiabatic process will not follow Boyle's law, it will not follow Charles' law also, it follow one of the law known as Poisson's law. Okay, and this Poisson's law is expressed by the relation PB to the power gamma is constant. So there is a factor that you can see, that is gamma. This is called gamma. This symbol is called gamma, but actually this gamma is actually given by Cp by Cb. And children, you have learned in details of this gamma as Cp by Cb. Okay, and this you learn in detail in the next unit, kinetic theory of gas. But just remember this, that adiabatic process follow what law? Poisson's law, and it's given by Pb to the power gamma is always constant. And actually this gamma is the constant, or quantity is a constant quantity, and this constant quantity actually determine the nature of the gas. because gas can be a monoatomic gas, it can be a diatomic gas, it can be triatomic gas. So that the value of the nature of this gas, if you take any of the ideal gas like monoatomic, diatomic gas, then the value of gamma will change. Okay, that's why the Poisson's law expresses the relation Pb to gamma is constant. So remember this part, children, that adiabatic process follow which law? Poisson's law, where Pb to gamma is constant and gamma is nothing but the ratio. This is actually the ratio between two specific heat capacities is at constant pressure and constant volume. So again I am telling you the detail of this you learn in the next unit. Okay, so there are other part to do continue, okay, with this adiabatic process, and that you learn in the next YouTube video.